All right, let's look at factoring a quadratic expression. For example, let's factor x squared minus 10x plus 21. To factor this expression means we want to write it as a product, x plus m times x plus n, where m and n are integers. Now think about what must be true. Let's FOIL this right-hand side. We have x squared plus n times x plus m times x plus m times n, or x squared plus n plus m times x plus m times n. So in order for this equality to hold, the coefficient of x on the left, namely negative 10, has to be equal to the coefficient of x on the right, n plus m, and then these constants, 21 and m times n, also have to be equal. That is, n plus m has to be equal to negative 10, and m times n is equal to 21. So let's start by looking at some factors of 21. And whichever factors of 21 add up to give us negative 10 will be the m and n we're looking for. So let's make a table here. So m, n, and n plus m. All right, so what are some factors of 21? We have 1 and 21. We have negative 1 and negative 21. We have 3 and 7, and negative 3 and negative 7. When we add these values together, 1 plus 21 is 22. This is not negative 10 that we're looking for. Negative 1 minus 21 is negative 22. It's also not negative 10. 3 plus 7 is positive 10, so it's not negative 10. But if we add these two factors together, yes, these add up together to give us negative 10. So therefore, we found our m and n up here. So our answer then is x minus 3 times x minus 7. This method of factoring is sometimes referred to as factoring by trial and error, because we're trying different factors of 21 until we find the ones that add up to negative 10. And let's verify to ourselves that indeed we did get the right factorization here. So if we FOIL this, we get x squared minus 7x minus 3x plus 21, which is equal to x squared minus 10x plus 21, which, yes, is our expression. Now, sometimes you'll see these problems done as follows. We'll still want to find these two numbers, n and m, that add up to negative 10 and multiply to 21. But then this negative 10x will be rewritten as follows. We still have the x squared, but then we have these numbers down here, negative 3 and negative 7, that add up to negative 10. So we'll rewrite negative 10x as negative 3x minus 7x, and then we still have the plus 21. And then we'll factor by grouping. So we'll group these first two terms together and the last two terms together. We'll factor out an x from the first two terms, which leaves us with x minus 3. And then we'll factor out a negative 7 from the last two terms, which also leaves us with an x minus 3. And then we factor out this common binomial here, which leaves us with the same answer of x minus 3 times x minus 7. Now, this is sometimes called the AC method because we want to look at a quadratic expression of the form ax squared plus bx plus c and find factors of a times c that add up to b. And in our case, a was 1 and c was 21. Now, this AC method is more commonly used when our a is greater than 1. So let's see an example of that. For example, let's factor 2x squared minus 7x plus 3. Let's compare it to the quadratic form ax squared plus bx plus c. So we see here that our a is equal to 2, our b is equal to negative 7, and our c is equal to 3. Let's apply this AC method that was just described. What we do is we multiply a and c together, so it's 2 times 3, which is 6. And we want to look at factors of 6 that will add together to give us our b, or a negative 7. And we find that the factors would be negative 1 and negative 6. Therefore, we rewrite this quadratic expression as 2x squared and then minus 1 times x, or just minus x, and then minus 6x plus 3. And then we factor by grouping. And from the first two terms, we can factor out an x, and we're left with 2x minus 1. And from the last two terms, we can factor out a negative 3, and then we're also left with 2x minus 1. Which then we can factor out this common binomial, which gives us our answer of 2x minus 1 times x minus 3. Now, how would we factor this? By trial and error. In other words, we want to try to write our quadratic expression 2x squared minus 7x plus 3 as a product of two binomials. But if we FOILed out these binomials, the first term would have to be 2x squared. So 2x and x would work on our first slots. And our last term after FOILing would have to be 3. So what are our choices here for the second slots? Well, we could put a plus 1 here and a plus 3 here, because 1 times 3 is 3. Or we could put minus 1 and minus 3, because minus 1 times minus 3 is also 3. Or the other way around, we could have minus 3 here and minus 1 here, as well as plus 3 here and plus 1 here. Now remember that our outer and inner terms would have to combine to give us this negative 7x. Therefore, this first choice here, this plus 1 plus 3, as well as the last choice, the plus 3 plus 1, can't work because their outer and inner terms would combine to give us a positive number, which means these middle two here would be our only possibilities. Now, what happens if we FOIL these two binomials out? We'd get 2x squared minus 2x minus 3x, which is minus 5x, and then plus 3. So our middle term is not right. So we'll cross this off as well. But if we FOILed these two binomials out, we would get to our original quadratic expression. Therefore, this is the factorization we found by the trial and error method. which is the same answer that we found by the AC method. All right, and this is how we factor a quadratic expression. Thank you, and we'll see you next time.